Swayam Prabha. Digital India. Educated India.
In continuation of permutation, let us go with generating permutation. So, generating permutation means a set with n elements and can be placed into one-to-one correspondence with a set of 1 to n, and we can have a list of the permutation in any set of n elements generating the permutation of n smallest positive integer, then replacing these integer with the corresponding elements. So, we have a many different algorithm developed to generate the n factorial permutation of this set, and we will describe one of these set is based on lexicographic or dictionary ordering of the set permutation of 1 to n. This ordering, the permutation a1 to an precedes the permutation of b1 to bn if for some k with k lies between 1 to n, and a1 equal to b1, a2 equal to b2 and so on, ak minus 1 equal to bk minus 1 and ak less than bk. In other words, a permutation of the set of n smallest positive integer precedes a second permutation if the number in this permutation in the first position where the two permutations disagree in smaller than the number in that position in the second permutation. So, this is the meaning of generating permutation, and we are applying in lexicographic order. Now, let us go with one example. The permutation 2, 3, 4, 5, 1 of a set 1, 2, 3, 4, 5 precedes the permutation 2, 3, 5, 1, 4 because these permutation agree in the first two position, but the number in the third position in the first permutation 4 is smaller than the number in the third position in the second permutation 5. Similarly, the permutation 4, 1, 5, 3, 2 precedes 5, 2, 1, 4, 3. So, this is one of the good example of generating permutations. Another example with the help of the problem, what is the next permutation in lexicographic order after 3, 6, 2, 5, 4, 1. So, the answer to the question is, first let us take the last pair of the integers aj and aj plus 1, where aj and aj plus 1 is less than the other is a3 equal to 2 and a4 equal to 5. So, the least integer to the right of 2 is that greater than 2 and the permutation is a5 equal to 4. Hence, 4 is placed in the third position. Then the integer 2, 5 and 1 are placed in order in the last three position, giving 1, 2, 5 is the last three position of the permutation. Hence, the next permutation is 3, 6, 4, 1, 2, 5. So, this way we can do that in the order of the a1, a2, a3, a4, a5, a6. Next, one more example, generate the permutation of the integer 1, 2, 3 in lexicographic order. Now, let us begin with 1, 2, 3. The next permutation is obtained by interchanging 3 and 2 to obtain 1, 3, 2. And next, because 3 is greater than 2 and 1 is less than 3. So, permute the 3 integer in 1, 3, 2, put the smaller of 3 and 2 is the first position, and then put 1 and 3 in increasing order in the position 2 and 3 to obtain 2 and 3. So, this followed by 2, 3, 1 obtained by interchanging 1 and 3 because 1 is less than 3. The next larger permutation has 3 in the first position followed by 1 and 2 in increasing the order, namely 3, 1, 2. Finally, interchange 1 and 2 to obtain the last permutation 3, 2, 1. We have generate the permutation of 1, 2, 3 in the lexicographic order, they are 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2 and 3, 2, 1. So, this way we can do the order of the lexicographic. Next, we have some algorithm of generating next permutation lexicographic order. See, algorithm 1 states that generating the next permutation lexicographic order, and that we have a procedure of the next permutation as A1, A2 and so on An, and permutation of 1, 2, 3 and so on not equal to n, n minus 1 and so on 2, 1. Now, just start with j is equal to n minus 1, while aj greater than aj plus 1 and j equal to j minus 1. J is the largest subscript with j less than aj plus 1. Now, you choose k equal to n, while aj greater than ak and k equal to k minus 1. Ak is the smallest integer greater than aj to the right of aj, and interchange aj and ak, therefore, r equal to n and s equal to j plus 1, while r is greater than s, interchange ar and as, therefore, r is equal to r minus 1, s equal to s plus 1. This puts the tail end of the permutation after the jth position in increasing order. Therefore, we have A1 to An is now the next permutation. So, this is a way we can develop the algorithm for generating the next permutation. Now, we have a detailed idea about that generating combination. How can we generate all the combination of the elements of a finite set? Because a combination is just a subset. We can use the correspondence between the subset of A1, A2 and so on An and bit string of length n. Now, recall that bit string corresponding to a subset as 1 in position of k if ak is a subset, and has a 0 in this position if ak is not in the subset. If all the bit string of length n can be listed, then by the corresponding between the subset and bit string, the list of all the subset is obtained. And recall that a bit string of length n is also the binary expansion of the integer between 0 and 2 power n minus 1. So, the 2 power n bit string can be listed in order of their increasing size as integer in their binary expansion. To produce all the binary expansion of a length n, start with the bit string 0, 0, 0 and so on with n zeros, then successively find the next expansion until the next expansion of the bit string is 1, 1, 1 is obtained. At each stage, the next binary expansion is found by locating the first position from the right, that is not a 1, then changing all the 1s to the right of this position to zeros and making this first 0 from the right A1. So, next example, find next bit string after 10, 00, 10, 01, 11. The first bit from the right, that is not a 1, is the fourth bit from the right. Change this bit to a 1 and change all the following bits to zeros. So, this procedure next larger bit string of 10, 00, 10, 1, 000 will come. So, this way first bit from the right, that is not a 1, the fourth bit from the right, then this bit to a 1 and change the following bits to zeros. So, this way we can bring what this bit string, next larger bit string like this. So, generating the next larger bit string with the help of the procedure. The procedure based on this algorithm to represent the next bring, how to do that, that is the parenthesis we have to do that bn minus 1, bn minus 2 and so on up to b naught. and the bit string not equal to 111 like that. Let us start with I equal to 0, while bi equal to 1, where I varies from bi varies from 0 to 0 and I varies, I is I plus 1 and bi equal to 1. Then bn minus 1 to b naught is now the next bit string. So, find the next larger 4 combination of the set 1, 2, 3, 4, 5, 6 after 1, 2, 5, 6. Here the last term among the term ai with a1 equal to 1 and a2 equal to 2, a3 equal to 5 and then a3 equal to 5, 6 and a4 equal to 6, such that and ai is not equal to 6 minus 4 plus I. So, these two are not occurred, that based on that we have a2 equal to 2. Now, to obtain the next larger 4 combination, increment a2 by 1 to obtain a2 equal to 3. Then the set is a3 equal to 3 plus 1 equal to 4 and a4 equal to 3 plus 2 equal to 5. Hence, the next larger 4 combination is 1, 3, 4, 5 and that is all. So, these things we can do with the help of for find the next larger 4 combination of the set. So, based on this we have to discuss an algorithm with display of pseudo code of this procedure. Algorithm 3 states that generating the next R combination in lexicographic order. Now, we have a procedure, next R combination as A1, A2 and so on AR, and we have a proper subsets 1, 2, 3 and so on n not equal to n minus R plus 1 and so on n with A1 less than A2 and so on less than AR, where I equal to R and ai equal to n minus r plus 1 and I equal to I minus 1, I equal to I minus 1 and ai equal to ai plus 1 for j equal to I plus 1 to r, and then aj is equal to ai plus j minus I, where a1, a2 and so on ar now the next combination. Next, let us start with probability and random process. So, for overview of this probability and random process is world a model builder sees is probabilistics rather than the deterministics. Some probability model might well describe the variations. So, our goal is review the fundamental concept of probability, understand the difference between the discrete and continuous random variables, and review the common probability models. So, these are all we are going to discuss the probability and random process. The outline of probability and random variables consists of random experiment and random variables, and probability mass and density functions, and expectation, variance, covariance and correlations. And also probability distribution consists of discrete probability distribution, continuous probability distribution, empirical probability distribution, right. Now, we have the widely used in mathematical ideas in probabilities in sciences, engineering, finance and philosophy to draw conclusion about the likelihood of potential events and underlying mechanics of complex systems. That is, the probability is a measure of how likely it is for an event to happen. We measure a probability with a number between 0 and 1. If event is certain to happen, then the probability of event is 1. If an event is certain not to happen, then the probability of the event is 0. So, these are all the ideas of measuring the probability. Now, the random experiments. An experiment is called random if the outcome of the experiment is uncertain. For a random experiment, the set of all possible outcome is known before the experiment. And number 2, the outcome of the experiment is not known in advance. So, these are all the things to understand the random experiment. Now, we are going to discuss sample space. Sample space denoted by letter omega of an experiment is the set of all possible outcomes of the experiments. For example, consider random experiment of tossing a coin twice. So, the sample space are, right, for coin we have a 2 faces, head and tail, and then 2 coins are tossing, then the sample space are HH, HT, TH and TT, right. Now, we are going to discuss event. So, event is a subset of a sample space. For example, tossing a coin twice, so that the getting 2 head is HH. In a tossing a coin twice, then we are having what? The events are HH, HT is the event of having a head in the first toss. So, this is the one of the examples of an event. And next, the general idea of probability is of an event. E is the numerical measure of the likelihood that event E will occur, and expressed as number between 0 and 1. Therefore, the maximum probability value is 1 and minimum is 0, that is nothing happen is 0. So, that if all possible outcomes are equally likely, then probability of E equal to cardinality of E by cardinality of total space, and then probability of the sample space is 1, mean both event and sample space are equal, therefore, it becomes 1. Next, independent event. So, 2 events A and B are independent if the occurrence of one does not affect the occurrence of the other, then probability of A intersection B equal to probability of A into probability of B. Now, we have an example drawing a single card at random from a regular deck of cards, and then probability of getting a red king is probability of A means getting a red card, that is P of A is equal to total number of outcomes of the card is 52, and a red card is both diamond and heart in is 26, therefore 26 by 52. Similarly, getting a king, right, the probability of B is equal to 4 kings are there in the well packed 52 card, therefore total number of outcome is 52, and then the possibilities of the event is 4, therefore 4 by 52. Similarly, probability of A intersection B equal to 2 by 52, therefore probability of A into probability of B if events are independent, therefore multiply them, we have this value, right. So, this way we can do that probability of A intersection B based on the independent event. Now, we are going to explain mutually exclusive events. The events A and B are mutually exclusive if the occurrence of one implies the non-occurrence of the other. In that case, the intersection between the two event equal to empty, therefore, probability of A intersection B equal to 0. For example, drawing a single card at random from a regular deck of cards, then probability of getting red club is A is getting a red card and B is getting a club, and then take the intersection, therefore, probability of A intersection B equal to 0. Next, complementary. Event of event A is event, not A, that is event that A does not occur, denoted by A complement. So, that is the meaning of complementary. So, event A and A bar are mutually exclusive, therefore, probability of A complement equal to 1 minus P of A. Next, union probability. So, union of events A and B is probability of A or B, that is probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. So, if A and B are mutually exclusive, therefore, probability of A union B equal to probability of A plus probability of B. For example, drawing a single card at random from a regular deck of cards. And what is the probability of getting a red card or a king? So, A means getting a red card, therefore, probability of A equal to 26 by 52, and B means getting a king. So, total number of king is 4, therefore, probability of B equal to 4 by 52, therefore, probability of A intersection B equal to, right, probability of A intersection B is equal to 2 by 52. Now, probability A union B equal to probability of A plus probability of B minus probability of A intersection B, and supply this value. So, that 26 plus 4 minus 2 equal to 28 by 52, that is the answer of getting a red card or a king. Next, conditional probability. Probability of event A given the occurrence of some event B, then probability of A by B is equal to probability of A intersection B by probability of B, that is occurrence of some event and based on that P of A by B. So, if events A and B are independent, probability of A by B equal to probability of A into probability of B by probability of B, so which is equal to probability of A. Therefore, one example based on this, drawing a single card at random from a regular deck of cards and probability of getting a king given that the card is red. Therefore, A means getting a red card is probability of A equal to 26 by 52, and B mean getting a king, probability of B equal to 4 by 52. Therefore, probability of A intersection B equal to what? 2 by 52. Therefore, probability of B divides A. Conditional probability is probability of B intersection A by probability of B A. Therefore, probability of B intersection A is equal to 2 by 52 and probability of A is 26 by 52. Therefore, we have 2 by 26 equal to probability of B. So, we have some numerical value associated with each outcome of an experiment. A random variable means is a function from the sample space omega to the real line that assign a real number x of s to the element s of omega. Therefore, x such that omega to r is a random variable. So, random variable takes on its values with some probability. So, that is the discussion of random variable. Further, example of random variable is, consider random experiment of tossing a coin twice. Therefore, the sample space is omega equal to HH, HT, TH and TT. Now, define a random variable x as the number of heads in the experiment. Therefore, x of TT equal to 0 and x of h comma t equal to 1, h of t comma h is 1, therefore, h of h is equal to 2. So, this is the meaning of finding the values of the random variable corresponding to the number of heads in the experiment. So, in first case no head, 1 head, 1 head, 2 head. So, according to that we have what? Random variable. Next, rolling a die. You take a sample space 1 to 5, 1 to 6, and then the number of rolled of x of I equal to x j, therefore, 1 less than or equal to j less than or equal to 6. Then the space is fair dice and observe the outcomes of the sample space I comma j is j varies from 1 to 6 and another I varies from 1 to 6. Therefore, integer from the first die and j is integer from the second die. Therefore, the possibilities of random variables corresponding to pair of dice is 1 1, 1 2, 1 3, 1 4, 1 5, 1 6 and so on, 6 1, 6 2, 6 3, 6 4, 6 5 and 6 6. So, these are all the possibilities of the random variable of the total sample space of a fair rolling a 2 fair dice, and these are all the outcomes, right, the possible outcomes. And then the random variable x is the sum of the two faces of the dice is denoted by x of I comma j equal to I plus j. Suppose if you take a probability of x equal to 12 and which is equal to probability of 6 comma 6, then the total number of outcomes is 36 and possibilities of the event is 6 6 only, therefore 1 by 36. Similarly, if probability x equal to 10 in the sense that throwing a die or rolling a die and total number of outcomes comes 10 or the possibilities only 5 5, 4 6, 6 4, totally the 3 possibilities, therefore 3 by 36. So, that is the random variable corresponding to this experiment. Now, random variable y, value of the first die is, suppose if y equal to 1, only one die, getting one value is 1, therefore 1 by 6, and I varies from 1 to 6, either it may become 0, 1, 2, 3 and so on. Out of this 1 only comes mean 1, therefore 1 by 6. Types of random variables having two types, one is called it as a discrete, another one is called it as a continuous. In discrete random variable, set of all possible values can be written as finite or infinite sequence. For example, number of requests sent to the web server. For continuous, random variables that take a continuum of possible values. For example, time between the request sent to the web server, right. Then probability of mass function. Let x be the discrete random variable and p of x I be the probability of mass function of x, where p of x I equal to p of x equal to x I, and then corresponding properties is the probability of x I is the highest value is 1 and lowest 0 and the summation of the probability is 1. Next, number of heads in tossing 3 coins. Suppose you take a 3 coins, tossing it, and the probability of getting 0 is total number of coin is 3, therefore total outcomes is 8, therefore only 1 zeros, that is nothing is available, therefore 1 by 8, and then in 1 is possibilities is 3 by 8 and 2 possibilities is 3 by 8 and 3 possibilities 1 by 8. Therefore, what? The probability of x I is equal to 1 by 8, 3 by 8, 3 by 8 plus 1 by 8, which is equal to maximum value is 1. So, this way we can get a probability of mass function corresponding number of heads in the tossing a 3 coins. So, 0 stands for no head, 1 head, 2 head, 3 head corresponding to this. So, this is a way we can draw that number of roll in rolling a fair die. For first case 1 only occurred 1 by 6, 2 only occurred 1 by 6, 3 only occurred 1 by 6, 4 only occurred 1 by 6, 5 only occurred 1 by 6, 6 only occurred 1 by 6 for rolling a die, and then the probability is 1 by 6, 1 by 6, 1 by 6, 1 by 6 like that, and then and sum them, it becomes 1. Now, probability density function. Probability density function is a continuous random variable, and then it defined by the rate of the random variable. Therefore, f of x equal to d by dx of f of x is the continuous density function, and we have to make a note of that. See, probability of x equal to x is 0 factorial, that is 1, and probability of x f of x is not equal to p of x equal to x, and it is denoted by one smallest increment of f of x into delta x. And this way we can write the what density function, and then the properties is varies from a to b, right, and then we have to find the area of this one, then a to b of f of x dx. So, if it has minus infinity and plus infinity, then the integral over this f of x is maximum is 1. Cumulative distribution function is a continuous random variable. So, the inspection device as a CDF of f of x equal to 1 by 2, and integral varies from 0 to x e power minus t by 2 dt, and integrate it. So, we have what 1 minus e power minus x by 2. So, the probability that the device lasts for less than 2 years is probability of x less than or equal to 2, which is equal to f of 2 equal to 1 minus e power minus 1, 0.632, and the probability that the last between the 2 and 3 is probability of 2 less than or equal to x less than or equal to 3 is f of 3 minus f of 2. Already we found out the value of this one is 1 minus e power minus x by 2, and x equal to 3 and x equal to 2 substitute it. So, that the value is like this. So, up to this I stop it, then we will continue from this area. Thank you.